In this module we talk about the while loop. If you recall from the previous module, the previous discussion, the while loop is typically used when you don't know how many times you're going to be executing the loop at the time that the loop starts. I'll now give you an example of exactly that using code. This is while.c. I've created this in the chapter 5 folder for you on the CD. Now remember from our course project first example, there were 3 lines of code, and those 3 lines of code are reproduced here for you, where we asked the user whether the CD is an album or a single, and we asked them to type an A or an S. And then we read one character from the keyboard, and if it's an A then we assume it's an album, and if it's any other character we assume it's a single. Okay, that's fine. What if they answer the question with a P or a full stop or the number 9? What should we do at that point? That's the question. What if the program specification was such that we had to produce some kind of error message and tell them to try again and to make sure they either type an A or an S? So what do we do? Okay, well let's have a look at that. Before this line of code here, before album equals type equals A, if you understand what I'm getting at, we need to actually check whether type equals A or type equals S or type equals anything else. And if not, then tell them that they've made a mistake, do the printf and scanf again, and then what? Well, then we need to do the check again, and then we need, if they get it wrong, we need to put an error message out again and do another printf and scanf, and so on 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 until they get it right. So in other words, we need a loop. So let's have a bit of a look at what that loop might look like. First of all, let's try and do it without a loop. Let's try this. Let's say if type does not equal A and type is not equal S, then what do we do? Well, we do this. We printf some kind of error, and then we do it again. We go and get these 3 lines of code again, copy and paste, and we have a look at that. We go, well, okay, now that works, or at least it looks like it will probably work. Yet we've only allowed for one possible mistake here. The user can make one mistake, but what happens if they make 2 mistakes? Think, oh well, we just need to do it all again then. You can see where this is going. If we copied and pasted this code, copy and paste, and just indented it all. Oops. Can you see this is just getting out of control? Of course it is, and this is obviously the wrong way to do it. So I'll just get rid of that second one and say, alright, now here is the key phrase, while. I've just replaced the word if with while. Otherwise the program is exactly the same. What happens? Well, first we ask the question, read the answer, we do a little assignment statement here, and then we say if the type is not A and it's not S, then we say there's an error, we ask them to try again, we'll read it the second answer, do the assignment again, and then what? Okay, now this condition here was the same condition as it was when it was an if a moment ago. So I'm sure you all can understand that if this condition is true, then we are going to go and execute these 4 lines of code. Okay, but what happens next? What happens after those 4 lines of code are executed? Well, the answer is this. We go right back up to this line again and evaluate the expression again. We evaluate that Boolean expression, in other words the condition, a second time. And if it is still true, then we go and do these 4 lines of code again. And then once we've done them again, we go and evaluate the condition again. And we keep doing it until that expression is false. As soon as that expression becomes false, we drop out of the loop and go to the next line after the end of the loop, which in this case is the F flush. That is how while loops work. It's quite simple. But it does mean that you need to understand that this condition gets evaluated every time through the loop, every time this condition is run. and is checked to see if it's true every single time. So that's probably fixed our problem. Let's have a look. We ask them the question, we get their answer, we see if it's not an A or an S. If it's not A and it's not S, then we go and do all this stuff. So if it is an A or an S, then we don't need to do any of that stuff. This line here means that the album variable has already been set correctly, so we simply move on and go down to here. So if there was an error, then we tell them that there was an error, ask them again, set the variable again, and go back and keep checking. Okay, so it looks like it will work. Let's put a little line of code at the bottom to tell us whether it's going to work or not. Okay, there's our modification. That will hopefully tell us whether we've got it right or not. That's exactly copied out of last chapter's program exercise. And now we go back up to here because I believe that we're going to need an F flush before every scanf. I know it's ugly, but that's probably what we need. Okay, we'll save that, compile, okay, run it. A for an album, S for a single. Let's try D. Error. Okay, let's try capital P. Error. How about capital S? Error. How about the number 4? How about a semicolon? Error, error, error. How about an A? Album. Excellent. That's much better, and the program's now finished. So it appears to be working. I guess we could check for the S case, but I'll leave that up to you. Okay, so our program works. However, I just don't like it very much. Why don't I like it? Can anyone else see a reason not to like this program? Well, this is why I don't like it. Because it has repeated code. These 3 lines of code here are perfectly duplicated. They've been duplicated right here. There's an F flush put in there, but we don't need to worry about that. We've got 3 lines of code, that one and those 2, that are duplicates. And I'm wondering, is there a way to rewrite this program such that they're not duplicated, such that they only occur once? Our program will be smaller when it compiles. It'll be faster to compile, and it might even be faster to run. Let's see if there is a way. What I'd like to do is somehow get rid of those ones out there and put them inside. Alright, let's try it. I'll just delete them and see what happens first. Okay. Now the first thing is we run this condition, which seems a bit meaningless at the moment because we haven't got type set to anything. The very first thing we do is we print an error. Okay, well that's clearly wrong, so I'll cut that away from there and I'll paste it down the bottom here, and I'll say if type does not equal A and type is not equal S. Then there's an error. How many people thought that I was going to write if type does not equal A or type does not equal S, as opposed to and? If you were one of those people that thought that I would type in type does not equal A or type does not equal S, if that would be your immediate reaction to that sort of thing, then go away and have a think about what that would actually do. That's a little exercise for you. Anyway, it's wrong. It wouldn't work. Now is this going to work? Well, it looks like it will work, except there's one thing missing, and that is right at the beginning here. This condition, well, it's certainly the right condition, but there is a problem. Type hasn't been initialized. Type is not set to anything at all. So I'm going to do a little bit of trickery here. I'm going to initialize type to, let's say, some character that we don't care about, like X. It could be any character. I don't care if it's X, just anything. Anything that's not an A or an S. Because making sure that it's not an A or an S will force this condition to be true. Type is not equal A, that's true, and type does not equal S, that's also true. They're both true, so the while loop will start when we will go in here. So now it will ask the question, do a little flush of the keyboard. It will read an answer, set that to true or false depending on whether type was A or not, and then it will print out an error message if there is one, and then it will go around the loop again. Now, if type was A or S, then this condition will now be false, and it will drop out of the loop and end up here. So, remember just a moment ago I tested the program and it worked, and the difference between that program and this program is that I have deleted 3 lines of code and I've added 1 line of code, that if statement. And I know that that if statement there is very, very similar to that while statement. So it's still a little bit of duplicated code, but it's less duplicated code than I had. I certainly don't have a duplicated printf or a duplicated scanf or a duplicated assignment. So it's an improvement. It's still a little bit of duplication and I still don't like it, but I don't have a good way, I don't have an improvement to show you that doesn't talk about stuff that you don't yet know about. Later on in this chapter we're going to discover the words break and continue, and when you know about those you'll be able to create this code, you'll be able to rewrite this code such that there is no duplicated code whatsoever. So let's see if this one works first. No errors, run, let's try the letter Q, no, number 2, alright, how about S, and that's a single. Okay, so that's working. Great. What I've just shown you is a fairly straightforward example of the while loop. It just goes around and around and around until the user enters the correct value. From our earlier conceptual discussion, you'll remember that of the 2 types of loops, this is the type of loop when we don't know how many times we're going to end up going through the loop when the program starts. It depends on how many times I want to keep typing in the wrong letters. Now I'll show you another example, and this time it will be an example of when we do know how many times we're going to go through the loop at the time that the loop starts. This time I'm going to show you the classic example of counting up to 1,000 and printing out the answer. Okay, let's have a look at it. This is while2.c. You'll find this in the chapter 5 folder as well. The program is reasonably complete, except that I haven't actually written the loop yet. Okay, all I have written is the initialization of total. Imagine if I deleted that. I'll just do that. I might put it back at the end and see how it looks. But for the moment I'm going to show you the while loop. We're going to start like this, and we're going to say while what? While some condition. Then we're going to add a number to the total. So we're going to say total equals what? Total equals counter. And perhaps counter, I know this is wrong, I'd just like you to think about what this might do. Counter plus 1. Obviously we're going to need some brackets around that because there's more than one statement. So if this was total equals total plus counter, and counter equals counter plus 1, what are we doing every time through the loop? Every time through the loop we're going to say, alright, take the total, whatever value was in the total, and add the counter to it, and then put the result back in total. Okay, that's fairly straightforward. We're incrementing total by whatever's in counter. So then we're going to go through the loop and say, alright, now counter equals counter plus 1. So the first time through, counter will be, say, 1, and then the second time through, counter will be 2, and the third time through it'll be 3, and then 4, and then 5, and then 6, and so on. Meanwhile, total will be going up by 1, and then it'll be going up by 2, and then it'll be going up by 3. In fact, we'll be adding up counter plus counter plus counter plus counter as the counter variable increments through 1 through 1,000. I hope you can see that that will give us the sum of all the numbers from 1 to 1,000, assuming that we know when to stop and assuming that we know how to start. So let's have a look at those two. Firstly, I need to say the terminating condition. While what? Can you think about what it would be? When do we stop? At what point do we stop? Well, it's when, counter, while counter is less than 1,000, or less than or equal to 1,000. It's because we do actually want to include the number 1,000 in our total. So when counter equals 1,000, we'll go through the loop. but when counter equals 1001, we'll stop going through the loop. Can you see that? Let's have a look at the terminating condition. Let's say counter is equal to 999 at this point. So we say, is counter less than or equal to 1000? Yes, it is. So we go into the loop. That was true. So we add 999 onto our total. And then we add 1 to counter, so now counter becomes 1000. Go back up to the top of the loop. We say, alright, now counter equals 1000. So, is counter less than or equal to 1000? Yes, it is, because it's equal to 1000. So we go back into the loop. Now we add 1000 to our total, which is good because we wanted to have 1000 added right at the end. And now counter equals 1001. Go back up to the top, and we say, right, is 1001 less than or equal to 1000? No, it's not. So stop and go to the end of the loop. Go down to the printf. Okay, so that's fine. There's only two things that are wrong here. Firstly is we haven't initialized counter. We're comparing counter to 1000, but we don't even know what counter is yet. We haven't set it to anything. It'll be some random number that may or may not be less than 1000. So we'll initialize it. What will we initialize it to? Can you think? Well, it's going to be 1 to start with. The first number we want to add to the total will be 1. And what about the total? Do we need to initialize that? Yes, we absolutely do. Because here we're examining, the very first thing we do with total is we examine the contents of it and we add it to counter and then we put the result back in total. Now this would be some random number. It could be 576, which we would then add to 1 and get 577, and that would go into total, and that would become our first iteration of total. So we definitely don't want that. We want our total to start with 0. We want to have nothing in our total before we start counting. Okay, so that looks like it would work. Let's test it. No errors. The sum of all numbers from 1 to 1000 is 500,500. And I'll leave you to determine whether that's actually true or not. Okay. So this is a really good classic example of a loop that counts up and does things with numbers for a certain number of increments until it gets to the end, and then it stops. We know at the beginning of the loop exactly how many times we're going to go through the loop. We know that we're going to go through a loop 1000 times. We know that because we're starting with 1, we're ending with 1001, and we're going up by 1 every time. So it must go through exactly 1000 times. We know that because we coded it that way. It doesn't matter which way we run the program, it's always going to be the same. So, we've seen the while loop now. We've got a fairly good understanding that the while loop, syntactically, is very similar to the if statement. It looks almost exactly the same. I could change that to an if, and the program would still compile and run. It may not work, but it would certainly compile and run. However, it's in fact a lesson on the while statement. So, syntactically I think we understand the while loop. How about conceptually? We understand it from the point of view where it will count up a certain number of loops. It will loop a certain number of times, an exact number of times if we need it to. And we've also seen the example in the previous example where it will loop an unknown number of times until a certain condition that's outside the scope of the control of the program is actually met. In other words, keyboard input from the user. Okay, so let's now move on to the next module in this chapter, which is about the for loop.